Imagine a tiny spacecraft, launched nearly half a century ago, now drifting through the farthest reaches of our cosmic neighborhood, sending whispers from a place no human-made object has ever ventured. Voyager 1, a relic of 1970s ingenuity, has just transmitted data that's turning our understanding of the universe upside down. What it's found at the edge of our solar system, a mysterious boundary called the heliopause, could rewrite the rules of physics and hint at forces we've never imagined. Stick with me, because this story isn't just about a distant probe. It's about humanity's boldest leap into the unknown and the secrets waiting to be unraveled. Launched on September 5, 1977, Voyager 1 embarked on a mission that seemed almost impossible at the time: explore the outer planets of our solar system and, if it survived, push beyond the sun's influence into interstellar space. This 722-kilogram spacecraft, powered by a radioisotope thermoelectric generator, carried instruments designed to study magnetic fields, cosmic rays, and plasma, tools that, by today's standards, are quaint but have proven astonishingly resilient. Its journey began with a grand tour of the gas giants, capturing the first close-up images of Jupiter's swirling storms and Saturn's majestic rings. Those grainy photos, beamed back across billions of kilometers, captivated the world and gave us our first real glimpse of the outer solar system. But Voyager 1's story didn't end with the planets. After slingshotting past Saturn in 1980, it set course for the unknown, drifting farther and farther from Earth. By 1990, it turned its camera back toward home, snapping the iconic pale blue dot image, a humbling portrait of Earth as a tiny speck in the vast cosmic ocean. Then, in 2012, after 35 years of travel, Voyager 1 achieved what no other spacecraft had. It crossed the heliopause, the invisible boundary where the sun's solar wind gives way to the interstellar medium. At roughly 18 billion kilometers from Earth, it became the first human-made object to enter interstellar space, a realm we once thought unreachable. Now, 48 years after its launch, Voyager 1 is over 24 billion kilometers away, more than 160 times the distance from Earth to the Sun. It takes light over 22 hours to travel that distance, meaning every signal we receive is a time capsule from nearly a day ago. Despite its aging systems and dwindling power, Voyager 1 continues to send back data that's nothing short of revolutionary. And here's where things get wild. Recent transmissions have revealed something at the edge of our solar system that scientists are struggling to explain. It's not just a blip or a glitch. It's a discovery that could change how we view our place in the cosmos. The heliopause, where Voyager 1 now roams, marks the outer limit of the heliosphere, a bubble of charged particles created by the sun's solar wind. This bubble shields our solar system from much of the galaxy's cosmic radiation, acting like a cosmic force field. Beyond the heliopause, the solar wind fades, and the interstellar medium, a sparse soup of gas, dust, and magnetic fields, takes over. Scientists expected this region to be relatively calm, with steady magnetic fields shaped by the galaxy. But Voyager 1's instruments have detected something entirely different: fluctuations in the interstellar magnetic field, like ripples or vibrations that defy our models. These magnetic anomalies, observed in data collected over the past few years, are puzzling because the interstellar medium should be stable over vast distances. Instead, Voyager 1 has recorded variations that suggest dynamic activity, almost as if the heliopause is interacting with something beyond our solar system. The signals are faint but consistent, showing patterns that don't match anything we've seen before. What could be causing these disturbances? That's the question keeping astrophysicists up at night, and the answers range from intriguing to downright mind-bending. One hypothesis is that these fluctuations are caused by plasma waves, oscillations in the ionized gas that fills interstellar space. Voyager 1's plasma wave subsystem has detected bursts of these waves, which could be triggered by shocks from the sun or interactions with the interstellar medium. These waves might be compressing or perturbing the magnetic field, creating the observed ripples. But here's the kicker. The strength and frequency of these waves suggest they're driven by something more powerful than we anticipated, possibly an unknown energy source or process in deep space. Another possibility is that the heliopause itself is more dynamic than we thought. Rather than a sharp boundary, it might be a turbulent zone where the solar wind and interstellar medium clash, creating eddies and currents that ripple through the magnetic field. Some scientists propose that these disturbances could be influenced by stellar winds from nearby stars, like Alpha Centauri, just 4.3 light-years away. Could our solar system be feeling the cosmic breeze from another star? If so, it would mean the heliosphere isn't as isolated as we assumed. It's part of a larger galactic neighborhood. But let's push the boundaries even further. Some researchers speculate that these magnetic fluctuations could be echoes of larger cosmic phenomena, like galactic magnetic fields or even shock waves from ancient supernova. The Milky Way's magnetic field, which stretches across tens of thousands of light-years, might be interacting with the heliopause, creating subtle vibrations that Voyager 1 is just sensitive enough to detect. If this is true, we're glimpsing a connection between our solar system and the broader galaxy, a link that could redefine our understanding of cosmic dynamics. Now, here's where your imagination might start to run wild, and I don't blame you. Could these disturbances hint at something even more profound, like an energy network spanning the galaxy? Picture invisible threads of magnetic or plasma energy weaving between stars, carrying information or influence across vast distances. While this idea borders on speculative, it's not entirely far-fetched. The universe is full of structures, like the cosmic web of galaxy filaments, that connect distant regions. Could Voyager 1 be brushing against the edge of such a network at the heliopause? If so, we're on the verge of uncovering a fundamental aspect of the cosmos. This discovery isn't just a scientific curiosity, it's a wake-up call. Voyager 1, with its outdated 8-track tape recorder and 68-kilobyte memory, is showing us how little we know about the universe. Its instruments, designed decades before smartphones existed, are capturing phenomena we didn't even think to look for in 1977. Every signal it sends is a reminder that exploration often leads to the unexpected, and that the cosmos is far more complex than our textbooks suggest. Let's talk about the human side of this story. Voyager 1's mission has always been about pushing boundaries, not just physical ones, but the limits of our curiosity and ambition. The spacecraft carries a golden record, a message in a bottle for any extraterrestrial finders, with sounds and images of Earth, laughter, music, greetings in 55 languages. It's a symbol of our desire to connect, to reach out, even if we never get a reply. And now, as Voyager 1 ventures into interstellar space, it's carrying that same spirit of discovery, challenging us to keep asking questions. The implications of Voyager 1's findings are staggering. If the heliopause is interacting with external forces, it could mean our solar system is more connected to the galaxy than we ever imagined. This could affect everything from space weather to the search for life. Cosmic rays, which are more intense beyond the heliosphere, play a role in planetary atmospheres and even biological evolution. If the heliopause is dynamic, it might influence how these rays reach us, shaping conditions for life across the solar system. Speaking of life, let's address the question that's probably burning in your mind. Could these findings hint at extraterrestrial activity? While there's no evidence of little green men, the disturbances at the heliopause raise intriguing possibilities. If the interstellar medium is more active than we thought, it could harbor conditions we haven't considered. Maybe not life as we know it, but exotic processes or chemistry that challenge our definitions. Voyager 1's data is a tiny piece of a massive puzzle, and every piece brings us closer to understanding whether we're alone in the universe. The scientific community is buzzing with excitement, but so are visionaries outside the lab. Take Elon Musk, whose SpaceX is pushing the boundaries of space travel. Musk has called Voyager 1's discoveries a cosmic wake-up call, urging humanity to accelerate efforts toward interstellar exploration. He believes these findings could inspire new technologies, like advanced propulsion systems, to send spacecraft beyond the heliopause. Imagine a future where we're not just receiving faint signals from 24 billion kilometers away, but sending probes, or even people, to explore interstellar space firsthand. Musk's vision, fueled by discoveries like this, reminds us that the impossible is often just a matter of time. Voyager 1's journey also highlights the power of long-term exploration. When it launched, no one knew it would still be operational in 2025, let alone sending back groundbreaking data. Its success is a testament to the engineers at NASA's Jet Propulsion Laboratory, who designed a spacecraft to withstand the harshness of space for decades. Even now, with its power supply fading, its plutonium generators are expected to run out by the early 2030s, the probe continues to defy expectations. Each signal is precious, a fleeting glimpse into a region we may not visit again for generations. As Voyager 1 drifts further into the void, it's paving the way for future missions. Concepts like the Interstellar Probe, a proposed NASA mission to explore the heliosphere, are gaining traction, inspired by Voyager's success. These next-generation spacecraft could carry modern instruments to study the heliopause in detail, confirming or expanding on Voyager 1's findings. But for now, Voyager remains our only eyes and ears in interstellar space, a lone sentinel at the cosmic frontier. So, what does this all mean for us, here on our pale blue dot? Voyager 1's discoveries remind us that the universe is vast, mysterious, and full of surprises. The heliopause, once thought to be a quiet boundary, is alive with activity we don't fully understand. Whether it's plasma waves, stellar winds, or something entirely new, these findings challenge our assumptions and push us to explore further. They also remind us of our shared humanity, our drive to reach beyond what we can see, to ask questions that have no easy answers. As we ponder these cosmic mysteries, Voyager 1's signals grow fainter, but their impact grows stronger. Each data point is a step toward a deeper understanding of the universe and our place in it. Maybe one day, we'll follow in Voyager's path, crossing the heliopause to discover what lies beyond. Until then, this tiny spacecraft, launched when disco ruled the airwaves, is our guide into the unknown, proving that even the smallest explorer can reveal the grandest truths. If this story of cosmic discovery has sparked your curiosity, join us for more journeys into the unknown. Hit that subscribe button and ring the bell. We've got more mind-blowing stories from the cosmos coming your way. Voyager 1's mission may be nearing its end, but the quest for knowledge never stops. What's the next impossible discovery waiting just beyond the horizon? Let's find out together.